Hello, guys. Welcome to my YouTube video. If you are new to this channel, please like and subscribe. In today's video, I am going to talk about this blog that I wrote, and I'll do a practical demo. In this video, we are talking about designing an incremental data extraction for a source data that is a SQL query. So what do I mean by this? Imagine you have a data warehouse or an ETL use case where you extract data from a source database, so be it a SQL Server or Oracle, and you use the ETL pipeline, you extract data into a staging database for like a consolidation point where you consolidate data from multiple sources. And then you take this data that has been staged in the staging database, you transform it, like do a bunch of joins and lookups and create your data mats or data warehouse. Now, when we have to design an incremental extraction process where we need to refresh the data from source to the target on a on a cadence, so be it every 2 hours, every 4 hours, or um, whatever nightly ETL or cadence that you want to build. Normally, we are very comfortable in pulling the data from the source, um, doing an incremental load from source to your staging using the tables, watermark fields like your last modified date to move the data across and keep it in sync so that, let's say, after your full load in your incremental load, you probably only need to extract only the data that was last changed. But in this process, we want to look a little bit around here. How do we take a query that has been transformed and do an incremental load on it and just extract only the delta records to the target? So, for example, if you see here, if you have a query like this, let's say it could be more complicated than this. And this is, if you think of this as your source query, how can we do an incremental, extraction of this query into a target? Now let's do quickly to a demo. If you haven't read my blog, please go read my blog. You will get a better understanding. Let's jump right into the demo. Firstly, we have let's create our source tables. So I'm using a PostgreSQL instance for this demo. So let's say we have a customer table and we create it. We have an address table. These are all our source tables and a city table. And we go ahead and insert some records into these tables. So customer table gets inserted some records. We run the select statement. We see the result. And we also run the address insert statement for the address table. And we see the results looking good. We have the two addresses for the two customers. Now we also insert a record for the city table, and we can see it right here. Now let's create a customer dimension. Let's say this is a use case where we have this is our staging tables that we have created, and we need to create a dimension table so that this table can be used to create reports on a customer. And what are the uh, logic or the goal of this customer table? The customer table dimension is to basically combine couple of source tables and denormalize it for easy reporting. As you can see, we combine the customer, the address, and the city. We got all the vital information into one dimension table, and I can run the query right here, as you can see. And now we're gonna push it to the dimension table. Now, so that we have done that for the full load, you could say. Now, let's think about we now go on a day two. We want to start doing incremental. So remember, we already talked about from data from the source to the staging is already handled for us. We already doing some kind of upsert logic, updating those staging tables the way we want it, like I explained in the architecture diagram here. This part is already covered. Now let's say this demo customer on day two got some records. So we're gonna simulate that by inserting some records here. Uh, we added a new record, Kenny Cox, and the customer. We're gonna update the address record in the address table. So we're changing it from 203 Main Road to 205 Main Road. So let's run that update and just note the date that we are updating the last modified date as well, so to reflect the latest date. Now, if we run our customer dimension, so if we run this query, we'll get the latest version of that customer dimension table. And this is the default process. What people normally do in the real world is, when they have a bunch of uh, pipelines and queries that transform and denormalizes data and loads it into a data warehouse or creates these dimension tables, they normally just truncate or totally erase the data from the target and repopulate it with the base tables using the logic that is defined. So that's perfect. That you can do that if you miss your requirement, if you miss your SLAs, by all means, truncate your dimension tables or fact tables, use the base tables, rerun it, and refresh it with the latest data. As you can see, we should get 3 records, and here we should get the 205 main road. So that one is the base case. However, we are trying to do something a little bit different here because we know in the real world we can have more data volume in our source and target systems. So it's not efficient, right, to keep regenerating all the records every single day. If you have 1 million records, why should we a pipeline run for hours if it can run in minutes? So that's what we are trying to do here, is to show how we can do this a lot better. And we can do this by using this incremental query. As you can see, what I'm doing here is the same query that I use for the to generate the customer dim. I'm using the same base query. The only thing I'm adding to find out the incremental records are the filters on the last modified date fields for each of the base tables, and I'm passing in the last ETL date. Now, how do I get this ETL date? You can get it by, I talked about it in the blog. There are many ways you can get it. The method I'm using here is to get the um, max, get this. If you get the max date from your customer date on the last modified date, that will give you the this date, right? And that you can use this as your watermark to filter for the new records. And notice I'm using an or because the point is we want to see whenever any change is captured across the base tables, generate those records. Another thing to note here is that when we built our dimension table, we decided to use the last modified from the customer uh, um, table, the customer base table, because we really know that our customer table is our driving table. Like you can see here, we always want to get the customer records, regardless if they don't have address or not. So it's a safe field to use for this use case. So when we run this query, we can see that we're gonna get the two records. So one was the record that was inserted, and one was the record that was updated. You see, like I said, is imagine you have a million records. Now you only get the two records that actually change. You're not generating the 1 million records every day. So what we'll do is we'll create a table. We will as we create use this to create a staging table. Call it a customer stage, which we're gonna use as our in our upstart logic. So now let's take a like be aware of what our customer dimension table looks like before we run our merge. So look at what it looks like. We have two records, and you see that for Lisa, the address is 203. Now, when we run our merge, which you all should know as well, I'm not going over that, but this merge statement is what we basically use to do the upstart logic. So we're gonna use the dimension as that's our target, our customer dimension, and our source is the customer stage. So we will use that to do this merge, and if it's matched, update. If when it's not matched, insert. So when we run this, it's gonna do the upstart logic, and when we look at our customer dimension, there you have it. You see that the data reflects the latest data according to what we should have in the based on the source tables. Now, also note that since we used the last modified date from the customer base table, that's what we will have, even though we did update this record as of um, um, in the address table, it was of a later date. However, we kept it uh, in this date. And the reason why we do this in this way is because the next time we run, we're gonna get the max from this table, which is always gonna pick up um, this record. so the January 20. So that will always help us know the last time that we extracted the data from our source tables, and we could get our incremental data from those. So that is basically the whole explanation of this, how to implement this. Read my blog. I will post this script in my GitHub as well. My link to the blog in the description of this video. So check it out. I hope this helps. Stay motivated and keep learning.